Yeah. So one thing that we considered is data. So this is a there is a data node. Then there is a link for a new node which is stored at the left side. Okay, at the left side, and there is a node which is stored at the right side. Okay, so the node which is at initial level, it is called a root node. Okay, this is the primary node which we consider, and we have availability of this node only, and rest other nodes can be accessed from this node only. Okay, so the structure that we will create is like here. I just make it new. Okay, and I'll share this Python screen. The screen visible?
Jupyter
Okay.
notebook, right?
Yes.
Okay.
Okay, so what we do in trees is first of all we create a class. So in linked list we have just two elements. Here we have three elements. So tree node will create, and in this tree node will create the structure def initialization of init and self comma data. Okay, and here what we'll do is self dot data. First one is self dot data is equal to base store a value, and then self dot left node is equal to none. We will store none value over here, and ONE, and then self dot right is also equal to none. So at initial level, we'll store this, and this will create our overall structure. Okay. Now, how we can do this in means how to create. So suppose we have a root node that is always initial node. So in linked list, we were taking the node one as the initial node. Here, since the structure is changed, and this entire structure will work in form of root and this. Give me a second. I need to connect charger. Otherwise, it will shut off. Okay. So first of all, there is a root node. So here, let's see, we have stored tree node, and here we are storing one value. Let's say I'm storing 10 over here. Okay, and then I am taking node A, node or node one. I am taking in node one. I am storing tree node, and I am storing, let's say, 5, and node 2 I am storing 3, node, and I am storing 15. Then node 3 I am storing 3, node, let's say I'm storing 14, and node 4 node I'm storing, let's say, 18. I will store these four. Let me take some a few more, then we'll create the connections. So node 5 is equal to tree node, and let's say this is 21, and node 6 is equal to tree node. Um, this is, let's say, 24. Like this, it will be enough. It's okay. Now we'll create the connection. So root node dot left. Root node of left is equal to, let's say I have created node 1, then root dot right is equal to node 2. So I have created the connection created the connection for left and right node. So right now this will be working like Um, First of all, well, हम्म, ये बड़ी समस्या है इसमें.
The screen went off.
Coming.
Oh,
Okay. So now, what it will be looking like? We have this. Yes. So what now the tree will be looking like? So here we have created initial 10 at the root node. So this 10 is at root node, and now at the left side the node 1. So node 1 is 5. So in left node 5 is stored, and in right node this is 15. So in right node 15 is stored. So we have initially created a tree which has three elements. Now we have to create the left and right for node 1 and node 2. So for node 1, let's say node 1 of left is equal to node 3, and node 1 of right is equal to, let's say, node 4. Then node 2 of left is equal to node 5, and node 2 of right, right, right is equal to node 6. So now we have created a node. I'm taking this at new space. So um, now our entire list is like, let's say, we have a node like this over here. Here we have 10. At the left side, we have 5. At the right side, we have 10, not 15. This is 15. And then left of 5. So what we have restored, left of 5. So node 1 of left is node 3. So this is 14. So here it is stored as 14, and here node 1 of right is node 4, that is 18. So this is coming as now 18. Okay, in the same way, if I talk about this, so left of this node 2 of right is node 5, so this is 21, and this right part is 24. So our tree by this is created like this. Okay, just by
yeah.
doing this, our tree is created. Now, if I want to see this whether the tree has been created or not, so since this is not a linear structure, this is a, you can say, left and right structure is there. So now how we can traverse in this tree? How can we see the values overall? Okay, so to see the values, there are basically three things are there. One is pre-order, then second one is in order, and third one is post order. Okay, so when I talk in the um, pre-order, it is acting like, first of all, there is left, then root, then right. Okay. In case of in order, it is like, first of all there is root, then left, then right. And in case of post order, first of all there is a left, then right, then root. So basically you can see here only, sorry, here this is in pre-order, root is first. Pre-order root is first, this is left, and this is right. And in order, root is second. So this is left, then root value, then right. Okay, so basically left and right are at same position, only the position of root is moving from left to right. So in this case, here in this example, we have like this, it is starting with 10. So I will see the code of it in a short while. I'm just telling what will be the output over here. So the output will be for pre-order. So it will start with the root, then it will go on left. So 5 will come, then it will go on again left of 5. 14. Now there is no left for 14, so it will search for right of 14. There is no right of 14, then it will go to the previous node that is at 5, and now it will search for right of 5. So this is 18. Okay, and now it will search for left of 18, no. Right of 18, no. It will go back to 10 now, right? Because for 5, left and right both are covered. Now it will go to 10, and it will search for right of 10. So right of 10 is there. It will get 15 over here. Then go to left of 14, 21. There is nothing at left of 21. There is nothing right of 21. It will go back to 15, and it will search for right of 15. It is 24. And now nothing is there. So it will stop. So this will be the output of pre-order. In case of in order, first of all, it will go to the left, then root, then right. So it will start again from 10 only. But since left is there, it will go first to 5. For 5 also left is there, so it will go to 14. Now there is no left for 14, so it will it, it, there is no left for 14. Yeah. So first of all, it will print 14 only. Okay. Now it will search the root of 14. So this is 5, and then now 5, 18, right? Then 5 part is totally covered. Now it will go back to 10. So 10 will come here, and then it will print, it will go to the right of 15, and from 15 it will go to again left. So it is 21, then 15, and then 24. Did you get?
Yeah.
Are you able to get how it is being processed in order? And in the same way, post order, first of all, it will print both left and right, and then it will go at the root node. So first of all, it will start with 10. Left is there. 5, it has come to 5. It will come again to left of 5, 14. There is no further left, so it will print 14. Now it will go back to 5, and it will search for right of 5. So it will print 18, and then 5 will be printed. And then after that, 21, 24, then 15, and then at last 10. Okay.
Yeah.
Are you able to get this? What's
Yeah.
happening here?
Yes, sir.
So basically, when we talk about the pre-order, so root node will come at first in the pre-order. Root node will come last in the post order always,
So
because
why
they are
is
taking.
in order and post order used?
Sorry.
Why are in order and post order used? Like, so post order is for uh 18, 5, 21.
There is no logic that why in order and order are being used. It is just basically the way of, means different way of traversing in the tree. This is way of
Okay.
traversing.
Okay.
Okay, this is not the algorithm. Basically, since tree structure is not a linear structure. So linked list was a linear structure. So easily just by doing next, you can go to wherever you want. But in case of pre-order and post-order, sorry, in case of tree is not a linear structure. So to traverse, you need a system, so that you can cover everything in the tree. By going randomly, if a tree is bigger, you will miss something, some values, right?
Yeah.
So basically, this pre-order, in order, post order, they provide a system of traversing within the tree. Okay. So now, if TreeNode. Why it is giving error? Root is equal to tree. Node node takes no argument. It is taking this argument. Why it is telling that it do not take any argument. Mm, mm, mm. It should take this tree node. Mm. It was working perfectly fine over here. Why it is giving error over there? I just created this sometimes back. It's worked fine. Then why it was not working with that? TreeNode class is fine. This def for def self of data. None. Oh, why it is giving this abnormal error? The now to look. Yes. double underscore is required for I design it. That was the error. Okay. Okay, so this tree is created now. Now what we have to do is we need to uh, traverse it using the different types. So first of all, we will traverse it using the pre-order. So we'll make a recursive function for this. So we'll check the definition pre-order, and we'll create with root node. Root node we have passed over here, and I am just telling if root is none. If root is none, then we have to exit, means return, else it has to process. So print. So what I am doing is, first of all, pre-order. So in pre-order, what order we follow? First of all, um, first of all, root, then left, then right. This order we follow, right? So root means print the root value first. So first of all, we'll do the printing over here. So uh, printing is not not here. We'll take node over here. Node. Root will pass when we'll call it. So node dot data, comma, to keep it in same line, we have to give this end. End end is equal to space this um space. Okay. And if it is and then again we have to do pre-order. We'll make a recursive function. Then node of left and pre-order node of right. Okay, so now what it will do is it will print. So let me execute this, and now I'll call pre-order, and with root I'll call. Okay, pre-order, pre-order root, not what it is doing. Okay, so now you can see here, this is the same thing where what we did. Now what it is, what we are doing is basically we are just traversing it. So first of all, for this tree that we made, uh, you can see this is starting with 10. 10 is the root node, the primary node that we say. Then it is going to left, then left of 5. And when left is printed, there is nothing left on the left side. Then it is going to right side, printing this 18 over here. Then 15 and this 21 we are making over here. Okay, understood.
Yeah.
In the same way, we can create the function for in order. So we can see just in order traversal. Okay, and instead of doing print over here, now we'll print over here. That's it. This is the only thing we have to do, and it will print. Okay, and I am just executing this, and what we can do in order traversal, and I am just passing the node root over here. Okay, here in order traversal, and I'll just execute this and execute this. So you can see now here root node has come at the middle. This is at left side and this is at right side. Okay.
Okay.
Any doubt?
No.
Mm, mm, mm. Now, the same thing we can do for post order as well. So we'll instead of in, we'll just post now, and post. This is post. Now, we'll just print. Take this from here, and we'll print it this over here. Okay. Now this is post order, and here we can write it as post order. Okay. Now I'll execute this. So you can see here now root node is coming at last. Okay. So this is how you can create your own nodes, and you can see how your tree is looking like. Okay.
Okay.
Any doubt in this?
No.
Okay. So now there are different types of trees are there. So Mm, if we talk about the trees, so we have multiple types of trees. Like this was just a simple tree. So this is just a simple tree, which has a simple tree. We can say this is binary tree. Okay, so binary tree means we have only left and right nodes over here. Okay. Now, next thing comes in this is which we usually say uh, that there are different types of trees. First of all, there is binary search tree is there. Okay. So in binary search tree, what happens is left is always less than the root and right is always greater than the root. Okay, so whenever a new node comes, it automatically searches its position inside the tree and it is inserted. Okay, so for example, if we have, let me tell you once, then I'll explain this again. So for means for example here in case of this if 10 comes, so 5 will come always left on this, and anything that is greater than 10 will come on the right of this. So that's what is binary search tree. So every time when new element is comes, when new element comes, it reaches it compares with the nodes for its own place. So now you cannot insert anything in this. The node will come and it will automatically decide based on the less than value or right greater than value. It will decide its place. But this can sometimes create a tree imbalance. Let's say more bigger values are coming, so tree may go on one side very lengthy, or on other side very small, right? So for that there is a concept of AVL tree. So AVL tree is basically known as height balanced tree. So what high balance tree is, if so the it always stores the difference of -1, 0 and 1 between the left and right tree. So maximum the tree can be either means difference of one element. If difference of more than one element happens, it performs the it performs the rotation. So if this balance goes beyond +1 or -1, it performs performs the rotation. Okay, understood?
Yeah.
Understood? Any doubt? Okay, so we'll see how these things are working, and we'll try to code them. Um, so let me show you how this thing works. So this is a normal tree which doesn't has anything in means any value can come at any position. So this is just a normal tree. Let's say if I talk about the binary search tree, BST, binary search tree. Mostly in our syllabus also we will be dealing with this binary search tree only. So now let's suppose one element is there um which is 10. Okay. Now a new element comes, like a new element comes, and the value of new element is let's say 14. So 14 is first of all it will be compared with 10, and it will automatically go on right side because 14 is greater. So 14 will come here. Now let's say a new element comes which value is 9. So 9 is less than 10, so 9 will come over here, and this will be inserted over here. Okay. Now let's say a new value comes, instead of 9 I'm taking 5 over here. Let's say 5 is coming here. Now a new element comes, like 8 has come, right? So 8 of 8 first of all it will be compared with this 10. Okay. And since it is smaller than 10, it will come on left. It will compare with 5. It is greater than 5, so it will store at right of 5. So this 8 will come here. Next, let's say next element comes as 12. So first of all, 12 will be compared with 10, and then it is greater, so it will go on right. It will be compared with this 14, so it is less than 14, so it will be stored on the left of 12. So like this, elements will be stored. Okay,
Yeah.
understood? Any doubt? Now let's say any value comes like 3, so 3 will be stored here. If a value comes like 6, so 6 will be stored here. Then if any value comes like no, 13, so 13 will be stored here. So every element will have its own place now, right? You cannot store any random element at any random place, and it will help you in the searching as well. For example, if somebody wants to search where is 11, right? So as soon it will come here, it will automatically transfer the call to here. It will not do the searching in the left platform, because now it's no, since 11 is greater than 10, it cannot exist at the left side. It will, if it is there, it will be existing at right side. Then 14 will be compared left, 12 will be compared left, there is nothing on left. So it will just with three comparison, it will say that the element does not exist, while we have many other elements as well, but it will not do compare with those elements. Understood?
Yeah.
Okay, so for means when these cases are there, so in these cases, what happens? If I talk about the pre-order, and if I talk about the in order, and if I talk about the post order, so you can see a noticeable difference. Like in pre-order, first of all, it will start from the left. So the extreme left is 3. So 10 to 5, 5 to 3 will be printed first. Then it will print 5. Then it will print from 5. It will go to right, and then at the 8, it is again finding the 6 at the left. So first 6 will be printed, then 8 will be printed. After this, 10 will be printed, and then it will print 12 and 13, then 14, and yeah, like this. So you can see here, um let me complete the in order as well. So in order, root will be printed first, then it will print second root, then 3, then 8, then 6, right? And then the same way, it will print 14 first, and then it will print 12, and then 13. And in case of post order, you can see here, first of all, it will print the left, so that is 3, then 6, then 8. No, no. For post order, root, yeah, root is at last. So 3, 6, 8, then it will print 5, then it will print 13, then 12, then 14, then 10. Okay, like this it will print in post order. So here you can see here clearly, when we have the binary search tree, pre-order will come in ascending order. You can see everything is there in ascending order, correct?
Yeah.
And in case of in order, the root element is at first. What I am telling, I'm getting confused with in order and pre-order. So in pre-order, root comes first, and in order, so this will come here, this will come here, and this will come here. Why I'm getting confused with between in order and pre-order again and again. Okay, so in pre-order, root is at first position, and post-order, root is at last position, and in order, all the elements are in ascending order. Okay,
Okay.
any doubt with this?
No.
So let me make a similar tree over here. I'll just I'll not write the algorithm today for this. I'll just try, just by random values, I try to make this binary search tree, and I'll just show you how this in order, pre-order, and post order are working. So let's tree, BS tree I am making, and this BS tree I am copying over here, 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 here. Okay, I have created this now, and what I am doing is, let's say, uh, here I am giving this as 40, and here I am 10, 5, 14, and then here I am giving um, 3, and I am giving 8 over here, and then I am giving 12 and 16. So now this is root 1, root left is node 1, node 1 is 5, and root right is node 2. So 5, 14, it will be in that order. Now node 1 of left is node 3. So node 1 is 5, and 5 left is 3. Then 5 right is 8. This will be there. Okay. And now Note 5 is Note 2, right? So Note 2 is this 14. 14 left is 12, and 14 right is 16. So yes, now it is arranged in the binary search tree order. Okay, understood.
Yeah.
And PS root I am giving over here. This name I am changing, otherwise it will create confusion. This name I have changed over here, and now I'll execute this. Yes, now I'll call this pre-order, post-order, and all these things. So first of all, I'll call pre-order, pre-order, in order, and post-order. I'll call it. Okay. So let's see. Here we have to give BS root. This is the root element. I'm giving it for binary search. Okay, and I'll now just execute this. It has come in one place. Print pre-order, comma, print in order, in order. This is closed, and then again print post order. Okay, now I'll execute this. Oh, one bracket is missing. Yes. So you can see here, this is what is pre-order, where it is starting with 10. Then this is the in order. It is in ascending form, and this is post order. Okay,
Yeah.
clear?
Yeah.
Any doubt with this?
No.
Okay, so this is how you can create your own binary tree, and mm, right now I have not written any algorithm over here. I have just simply assigned based on the left smaller and bigger values. I have just assigned over here, and I there is no algorithm as of now. Right, we'll write this algorithm together tomorrow. Okay,
Okay.
are you able to understand this?
Yeah, yeah.
What is the basic concept of this?
We are traversing in the tree in three different ways.
Hmm. So now this is done. Now let me introduce with you with the AVL tree also. So AVL tree is basically, we say AVL tree as the height balance tree. So in height balance tree, what happens? Suppose initial value comes as let's say 10 is coming over here. Okay, now one value, when there is no left no right, so number of left and number of right will be counted, and with the when number of left and number of right will be same, so the balance value will be 0, right? Right now
Yeah.
there is no left no right, so balance value is 0. Now let's say a value has come over here, that is 5. Okay. So now what will happen? One new value has come at left side. So now left length is 1 and right length is 0. So 1 minus 0 is now 1. So it is balanced, right? Now let's say a new value has come at this place, and this value is, let's say, 8. Okay. Now the number of nodes at the left side is 2, right? So this is 2, and at right side it is 0. So now the index value of this is 2. So now this is imbalanced tree. So when this is imbalanced tree and this is plus 2, so this is positive, means positive means left side has more elements. So when left side has more element, this root node will be rotated towards the right. So what will happen now? 5 will come at the root, and 8 will be um, No, five will not come at the root, because this is the height balance tree, and this is again a binary search tree as well. So to maintain that consistency, what it will do, it this 8 will come at middle position. 8 will come over here. Okay. And then 5 will be at the left side of it, and 10 will be at right side of it. Okay. So as soon this index, this value, it goes either more than 1 or less than -1, right? So
Yeah.
when the right tree will be more, it will go towards the minus. If left tree is more, it will go towards the left. And as soon it crosses, it automatically balances the tree. Okay, understood.
Yeah.
So this will learn after we do everything with the binary search tree. We'll see how we can implement the AVL tree also. Then apart from AVL tree, I guess do you have the B tree in your syllabus?
The B tree.
Yes. AVL tree I saw. I did not see the B tree. Just confirm whether B tree is there or not.
Is it like spelled as B double E or B just B?
Just B. Just B. B for Barcelona.
One second. I'm just checking. Yeah, it is there in a
B
different.
tree is there.
Yeah.
Okay, we'll do the B tree as well. No worries. So for now, just understand this, and then later onwards, we'll learn the B tree also. In B tree, there is splitting techniques are also there. It is a little complicated. No worries, we'll do that as well.
Okay.
Okay, so we'll keep it at this for now, and just try to complete